Welcome back, Calculus. I hope you all are well. Our objective today is going to be to approximate area under the curve using Riemann sums. This should be a review of pre-calc. If it's not, make sure you take really good notes, okay? Because this is something that, although it really is a pre-calc concept, appears on the AP exam quite a bit, both on multiple choice and free response. So I've got the checklist on the screen. You know what to do from here. All right, as a review from our last lesson, to find the total amount or total accumulation, we find the what under the what function. We find the area under the rate function, okay? And our notation for this in symbols, when we are trying to find how much or area, we use an elongated S, that's called the what symbol? Called the integral symbol, okay, and we go from some time A to some time B, okay, those are called your limits of integration, and then we want to take the area of our rate function, so R of t would represent your y value, which would be your height of each rectangle, and then dt would be your infinitesimally small or thin base, okay, of each rectangle. So this is our notation if I want to find the area under the function r of t from time equals a to b. And when I talk about area under the curve, I mean the area made with the curve and the x-axis. Okay. All right, so a couple kind of basic examples here. So let's say I biked at a constant rate of 10 miles per hour for 40 hours. So I went a total of how many miles? Total of 40 miles, right? And now let's graph the situation. So what I've done is my y-axis is representing my velocity or my rate. So I'm going to call this axis v of t. And then my x-axis is representing my time, okay? So how can I get 40 out of this graph? Well, let's take a look here. If I connect, again, my function to the x-axis, and then take the area of between my function and the x-axis, then I would get 10 times 4, which is 40, right? And if we look, our units would work out for us as well because v of t, remember, was in miles over hours, and time was in hours. So when we multiply miles per hour times hours, the hours are going to cancel, and you do indeed get 40 miles. All right, so let's say that this time I went mountain biking. I biked at a difficult 5 miles per hour uphill for 3 hours, and then breezed down the mountain at 15 miles per hour for 1 hour. So I went 5 times 3, which is 15, and then another 15 down, covering a total of 30 miles. Okay, and first pause on the screen, can you try to graph this situation? So again, let your y-axis represent your velocity, okay, your speed in this case, and then your x-axis represent time. You do want kind of a stair-step function here. That'll be my hint. So hit continue when you're ready to check your answer. So our velocity function should look something like this. So from time 0 to 3, I traveled at a constant 5 miles per hour, and then from hours 3 to 4, I traveled at 15 miles per hour. So if I want to find the area under this red curve now, and again, area under the curve means the area between the curve and the x-axis, what can I do here? We make 2 rectangles this time, right? This rectangle is going to have an area of 3 times 5, so 15. And then this rectangle is going to have an area of 1 times 15, which is also 15. So there is my 30 miles that you predicted. So the point is that if I'm taking the area under my rate function, in this case my rate was velocity, then that gives me my total accumulation, okay? Now, the thing is that our functions usually are not these nice piecewise linear functions, right? Typically in real life, things move at moving rates, okay? So even our rates vary. So what we're going to do is practice approximating area under the curve using rectangles first, and then soon, very, very soon, we'll learn how to figure out the exact areas of kind of these wonky shapes using calculus. All right, so I want to show you some ways to approximate area under the curve using a shape that we are very familiar with, which is the rectangle. These are called Riemann sums. So what I've done is I've graphed y equals x squared plus 2, and what I want to look at is the interval from x equals 0 to x equals 4. Okay, so try to picture the actual area. So the actual area, look at your curve here, and then I would connect to the x-axis. It would be this piece here. Okay, what we're going to do is approximate this area using rectangles. So there's 3 different rectangular approximations we can use. The first one is called your left rectangular approximation method, also known as LRAM. So what we're going to do is, let's say I'm going to let n be 1, that's your number of rectangles. So if I make one rectangle using my left subinterval, it's going to look like that. Okay, so there's LRAM using one rectangle. Not the greatest approximation, right, for the actual area. Now, if I move it and do 2 rectangles, do you see your approximation is getting better, right? If I continue to do more rectangles, notice for each interval, let me do 4. I'm using my left y value. So here, 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 and here to create the height of my rectangle. And to determine the width, I just say, okay, I'm going from 0 to 4. I want 4 rectangles. So in this case, if I split them evenly, my base would be 1 in each instance. Okay. Now, the more rectangles I use, look, the better approximation I get. See? So to get the exact area under the curve, how many rectangles do you think we need? An infinite number of rectangles, and that's where calculus comes in, right? Because calculus is all about the study of infinity, and that's where we need limits. So the problem with lots of rectangles is that's lots of work, right? So the fewer rectangles, the worse the approximation, however, the easier the approximation, right? So that is what LRAM looks like from 0 to 4 with this particular function. Let's take a look at RRAM. Let's go back to 4 rectangles. So here is RRAM, again with 4 rectangles. So this time notice to create each rectangle, I'm using the right y value of the function. So here's my first height, my second height, third height, and fourth height. Base in this case, if I want to do 4 rectangles, would be base of 1, okay? So this is RRAM. Notice more rectangles, better approximation, right? But more rectangles also equals more work. Okay, the last kind of rectangle we can use is called MRAM, which is your midpoint approximation. So notice to get your height here, you just go literally to your middle y value, okay? So in my subinterval here goes from 0 to 1. So right in between 0 and 1 is a half. So when x is a half, I just go up to my function there, and whatever the y value is there, that creates the height for my whole function. Hopefully you can see that this is a pretty good approximation method. In this case, it was better than LRAM and RRAM. And again, more rectangles, the better the approximation. Okay, so hopefully you have your blank notes from class. You can go ahead and pull those out. We'll fill these in together. So the first one says approximate the area under the curve between 0 to 8 using the right rectangular approximation method, or RRAM, and 4 rectangles. We'll assume the rectangles are of equal width, okay? So if I'm going from 0 to 8, so from here to here, and I want 4 rectangles of equal width, how long should each width be? Should be 2, right? So let's mark those off. Let's go 0 to 2, 2 to 4, 4 to 6, and 6 to 8, okay? Now if I want to use RRAM, the right rectangular approximation method, what I'm going to do is come grab the, so 2 is going to be your right endpoint, right? So find what y is when x is 2, which looks like about 2.5, and that is what's going to create my first rectangle, right? So my first rectangle has an area of, well, let's do this, a base of 2 and a height of 2.5, so an area of 5, right? Okay, let's look at the second rectangle. So base goes from 2 to 4. 4 is my right endpoint, so when x is 4, come find your y value there, and that's what the height is going to be of your next rectangle. Okay, so I'm just going to add that next area. So my base is 2 and my height is 1, so I'm adding an area of 2. Okay, all right, the next rectangle goes from x equals 4 to 6. When x is 6, my y value is 4. So my rectangle looks something like this. So I'm just adding that area. So my base is 2, my height is 4, so my area is 8, right? Okay, and then the final rectangle goes from x equals 6 to 8. 8 is your right endpoint, so find the y value when x is 8. It's going to be up here. And here is my final rectangle. So again, adding on, I've got a base of 2, a height of 1, so that's an area of 2. So my RRAM approximation with 4 rectangles in this case is 17. All right, same graph. This time let's do LRAM. So I still want 4 rectangles. Again, we're assuming equal bases here. So let's mark off 0 to 2, 2 to 4, 4 to 6, 6 to 8, okay? So that first rectangle, if I go to my left endpoint, x is 0, what is y there? Y is also 0. So my base is 2, but my height is 0, so my area is 0 there. Okay, all right, and see if we have better luck with the next rectangle. So base, or the left endpoint is 2. When x is 2, y is 2.5. We've seen this one before, right? So here is my second rectangle. So adding on, I've got a base of 2, height of 2.5, so an area of 5. See if you can do the next 2 rectangles on your own. Hit continue when you're ready to check. All right, here are my rectangles. I got 15 as an approximation. If that's not what you got, double check, and go ahead and pause if you need to. All right, let's try MRAM. Remember, M stands for midpoint. I'm still using 4 rectangles, so let's still go ahead and mark off 0 to 2, 2 to 4, 4 to 6, 6 to 8. For this first subinterval from 0 to 2, your midpoint is x equals 1. So find what y is when x is 1, which is up here, right? That's going to be your height still for that entire subinterval from 0 to 2, okay? So here is my first rectangle. So base of 2, height of 2 for an area of 4, right? Let's do one more together. So the next subinterval goes from x equals 2 to 4. The midpoint is 3. So when x is 3, y is up here, y is 2. So I'm going to create a horizontal line, so y value of 2 for that entire x interval, okay? So base is 2, height is 2 again for another area of 4. All right, force pause on your screen, see if you can try the next 2 rectangles on your own. And I got 20 for this approximation method. And just so that we're on the same page, the actual area that I'm approximating is all of this stuff, right? Can we picture that? So it's the area between the function and the x-axis. Okay, so that's what we're trying to approximate here. We've been using 4 rectangles. Again, if I were to use more rectangles, I'd get a better approximation of the actual area, but it would also be more work, right? Okay. All right, so there's actually one more approximation method. It's not rectangular, it's using trapezoids. But so I wouldn't go over the area of a trapezoid, but I really want you to link trapezoid as just a fancy rectangle. Okay, so I've got a particular trapezoid here. I'm going to call this a base of 2 and heights of 4 and 6, which is using different terminology than a geometry textbook, but it's okay, we're in calculus. So now my question for you is, if I were to come right in between, this is a line segment right here, right? So I were to come right in between here, and if I were to draw this rectangle, do you agree that my new rectangle has the same area as my trapezoid, right? Like, I don't capture all of that area, correct? But I make up for it right there, okay? So this trapezoid has the same area as the rectangle with base 2 and height what? Height 5, right? And how did I get 5? I just averaged 4 and 6, okay? So let's write the general formula for an area of a trapezoid with that blank you have there. Okay, so if my area is still going to be base times height, okay, so let's write that, still going to be base times height, but my height let's maybe put quotes around height, huh? My height is going to be the average between my two endpoints, okay? So my height is going to be whatever this number is plus this number divided by 2, right? So that is going to be how we find area with the trapezoid. All right, so let's try this one. So we're still going to do 4 subintervals, so 0 to 2, 2 to 4, 4 to 6, 6 to 8, okay? So now to draw them out, I'm going to take my left endpoint, my right endpoint, connect the 2, and then drop down to the x-axis, okay? This is a triangle because my left height is 0, but let's go ahead and follow our formula. So base is 2, then I'm going to average my y values, which are 0 and 2.5. So let's do this. Let's just write it as 0 plus 2.5 divided by 2, right? Okay, next one. I'm going to take my left y value, my right y value, connect the 2, drop down to the x-axis. Okay, so base is 2, height is the average of 2.5 and 1, right? Okay, let's look at the next one. Take your left y value, your right y value, connect the 2, drop down to the x-axis. Okay, so base is 2. The height is the average of your y value. So here your y value is 1, here your y value is 4. So 1 plus 4 over 2. All right, and then the last one, connect your left y value to your right y value, drop down. So I'm going to have an area, base is 2, height is the average of 4 and 1. Okay, the reason why I kind of left it like that is because, look, all your 2's cancel now. Multiplying by 2, dividing by 2, undo each other, right? So we can just add those up, and we should get 16. All right, the most common way you will actually see these on the AP exam is with tables. So let's take what we just did, because a table, I can mentally kind of think about plotting those points and do exactly what we just did with the graph. So even if the graph isn't given, it is, I think, pretty intuitive to switch from a graph to a table. So number 1 here says approximate the area under f of x from -1 to 3 using RRAM and 8 subintervals, okay? So think about that, going from -1 to 3, that's a length of what? Of 4, right? And if I want 8 subintervals, each subinterval needs to have a length of a half, right? And that's exactly what's on your table. So the first thing I'd really recommend is actually looking at your base for each rectangle. So -1 to -0.5, if you can think of that on your x-axis, will have a length of 0.5. Each of these will have a length of 0.5. So even though it seems a little tedious now, and really truly just look at, okay, what's the difference for each subinterval? And it doesn't have to be the same length. It is in this case, but it won't always be. So it's a really good idea to mark off the length of your base. So in each case here, like if I go from 0 to 0.5, that's a length of 0.5, right? Okay, now I want to use RRAM. So what I'm going to do, this first subinterval goes from -1 to -0.5. The right x value would be -0.5. So let's come grab the right y value there for the height. So first rectangle is going to have a base of 0.5 and a height of 4.25, right? The next rectangle will also have a base of 0.5. And this time for that second subinterval, the y value on the right is 4, okay? And so on and so forth. See if you can fill out the rest. All right, so we should have gotten this kind of lengthy thing. Notice that you do have a factor of 0.5 in each one, so I could have factored that out. And we should get, and feel free to use a calculator here, 27.5. All right, can you try number 2? I do want you to be real careful. You might want to count up every time that, yes, okay, I do have 8 rectangles, because it's really, my caution is make sure you don't use that 13 at the end. So go ahead and hit continue when you're ready to check your answer. So we should have gotten those 8 y values added up and then multiplied by 0.5. All right, let's talk about midpoint. This time we need to use 4 subintervals, or that's what we've been asked to do. So let's go ahead and mark those off. So if I'm just using 4 subintervals, this time my length will be 1 in each instance, which is a nice number to work with, right? So from -1 to 0, 0 to 1, 1 to 2, and 2 to 3. Okay, now if I'm using midpoint, I would come grab the middle y value, right? Make sure I'm doing that. There we go. So let's try set that up for me. So we should have gotten these 4 areas. Okay, last one, trapezoid. Still 4 subintervals, so I can keep my bases. Now for my height, what word do I want you to connect to trapezoid? I want you to connect the word average. Okay, so for my height, for this first one, I'm going to average 5 and 4. So base of 1 still, and then I'm going to average 5 and 4, right? My next rectangle, base of 1, this time I'm going to average 4 and 5. The next one will have a base of 1 still, and now I want to average 5 and 8. And then lastly, a base of 1, and I want to average 8 and 13. And by the way, on an FRQ, please leave it like this. All right, so that is Riemann approximations. I will see you all next time.